Hi, and welcome back to this new lecture in the computer security module. Today we will be talking about XACML, which is an industrial standard for specifying security policies. So remember from last time we talked about access control, and we said that access control represents the idea that you control access to your resources and any sort of technologies and models that come along that, okay, so that help implement that idea. Today we will be talking about a language which is used extensively in industry, and it's called XACML. It's called XACML because it is essentially a schema of XML. Okay, so it's a schema of the extensible markup language, or what's known as XML. But that schema is specific for implementing access control policies. Now, remember we said also last time that the idea of access control is often implemented via this model that we call the reference monitor. And we said that a reference monitor is that layer of intelligence, or that layer of the system which sits between you as a subject or a user who wants to access certain resources and the resources themselves that you want to access. And the idea of reference monitor makes use of the concept of a policy, and policies are stored usually in what's known as a policy database, where they can be retrieved easily by the reference monitor. Of course, the policy itself is, and as we will see today, is nothing more than just a collection of the rules that you want to write down so that you can protect your resources. And when we talk about protection here, it can mean either security protection, so you're protecting the privacy or the integrity of the data that you have, but it can also mean any other form or any other definition for protection. So it could also be essentially protecting your resources from being overused or from being stolen, or any kind of protection you can think about. Now, as we said, XACML essentially stands for the Extensible Access Control Markup Language. Is basically, you can think of it as a special schema, special XML schema, which has been crafted to particularly express access control policies and access control rules in distributed systems. It has been for many years now an OASIS standard. Okay, so you can look up the OASIS website, and you will see all the specifications for this language, and you will see the working groups that maintain those specifications. It basically is not just a language, it also defines an architecture. So it gives you the language and the meaning of that language, but it also defines an architecture that you can basically, sort of take off the shelf and implement in your organization. Or if you are essentially buying any products or technologies that will enforce an XACML type policy, then you will at least have some basic understanding of what the architecture of that product is, or the architecture of the system required for enforcing and specifying XACML policies. The architecture consists of a number of what we call points. So you have something called policy enforcement point, which is the point at which a request is intercepted. You also have something known as a policy decision point, which is essentially an implementation of the intelligence found in this thing that we call reference monitor. So moving forward, we see here the architecture in a diagram, an XACML architecture. So you have the client or the subject who would like to access certain resource. So they can send a request, and that request is then intercepted by the policy enforcement point, so that it can be evaluated against the organization's policies, whether that request is legal or lawful or it's illegal. And if, of course, if it is a legal request, then it will be authorized. Okay, so you will then gain access to the resources. If it isn't, then you will essentially return back an error to the client, or some kind of sort of information saying that you are not allowed to access the resource. Of course, all of this is done keeping in mind the actual policies, and those actual policies are evaluated by what we call a policy decision point. Okay, so this is the decision point in your system, which essentially means it's the intelligence, it's all the rules that you have crafted and written in order to express the policies of your organization. Okay, so the request is then forwarded to this policy decision point, which contains all the policies, and it is then evaluated, or whatever policies that are applicable are then evaluated on that request, and this decision is reached as whether to yes, allow, or no, deny the request and send the client back home. Right, so as we said, XACML is nothing but a special schema of XML. We will not discuss XML in length here, but this is just a short slide just to explain, or to kind of give a recap of what XML is. XML is kind of a markup language which is extensible. It's used for essentially defining attributes of your document. So if you think of the of an HTML document as being sort of a language that allows the styling of your information, how the information should look like. XML is essentially an attribute-based language. So essentially, it gives for each piece of information, it gives the relevant attributes, or you can mark that particular piece of information with the relevant attributes here. So for example, the title of person, Mr. or Mrs., you can mark it up as a title. Okay, so you add the title tag. The first name, you can mark it up with a first name tag. Last name with the last name tag, address information with the various address information tags. Now, of course, these tags are extensible in the sense that they are user-defined. You can define any tags you wish that best describe the attributes of your document. Ultimately, this kind of approach facilitates the exchange of documents across multiple systems or multiple machines, because they can all agree, for example, on what kind of attributes they want to communicate with one another. The main features of XACML, basically in this lecture and in this week's material, we focus on version 2. Okay, so there are 3 versions of XACML: XACML 1, 2, and 3, and they all are sort of widely adopted. However, we focus on version 2 simply because there is a tool for editing and for writing XACML policies, and that essentially facilitates our learning process. As I said a couple of slides ago, it is a rule-based language. Okay, so it's a rule-based language, meaning that ultimately everything that you write down is going to end up being a rule. Okay, so we will see what a rule means, but ultimately everything that you write down becomes a rule. So a rule is the basic building block for the XACML language. I was going to say that that the language is not just a language that allows you to express authorizations, so what is permitted to happen, what kind of requests are permitted, but it's also a language that allows us to express what's known as obligations, or the idea that you can specify certain rules that tell you what you must do as a system in case you, for example, in case you accept a certain request, what should you be doing to follow that request up? So that's the concept of obligations, but our focus will be on simply on authorizations, and we keep it at a simple level. Right, so this is a nice diagram which demonstrates quite neatly what the structure of an XACML document, policy document is. As you know, like any other XML document, it will have a structure, and that structure is represented by the various attributes which are used to mark it up. However, the attributes are not written in a flat way across the document, but they can be nested within one another. Okay, so to give you an example, if you could let's say start with an attribute which represents the address, the physical address of a person, and within that address you can have sub attributes which basically represents the different components of that address. So the street name, the house number, the postcode, the town, etc. So in a similar way, even with XACML, we have that kind of nested structure. And this diagram basically explains what that nested structure is. You can think of it in a simple way as follows, that each XACML document can start with a top-level attribute or a top-level tag which represents a policy set. Then a policy set contains within it a number of policies, as the name suggests, a number of individual policies. Then if you look at each individual policy, you will see that it contains within it a number of individual rules. Okay, and of course a rule contains other sub attributes within it, but it's not composed of a number of other things. Okay, so a rule is, at the end of the day, is the most basic building block that any XSML policy or XSML policy set will consist of. Now, the rest of the lecture goes through this structure, examining what the elements of each attribute are. Okay, so we start with the topmost element, and that's the element of a policy set. So as we said, a policy set, and as the name suggests, is an attribute that expresses a set of policies. Okay, so you have here your top level attribute, which is basically saying that whatever you will see within this document is a set of policies. Okay, and as the name suggests that it's a set of policies, you will find within that element, policy set, a number of individual elements which are of type policy. Okay. So a policy set simply consists of a number of individual policies. So here's an example, a simple example. You have a company that publishes geographical maps. Let's call it GMP. And this company consists of two departments, a publishing department and a marketing department. Now, of course, if we want to set up a policy for this company, we will have then to set up a couple of individual policies. One policy is for the publishing department and the other policy is for the marketing department. However, the two together, they construct or they define together a policy set, which is the policy set for this company called GMP, this hypothetical company called GMP. Now, let's have a look at the element which is policy. The element itself, as we said, then is nothing other than the grouping of a number of more basic individual elements, and in this case, those elements are the rule elements. Okay, so in other words, a policy is just an alias for defining a set of rules. So if we go back to our example here, we see that the GMP publishing and marketing departments, we said they each have their own individual policy. Then we see that the publishing department, for example, will contain three rules. The first rule is for, or it's a rule that controls the editing of the different geographical map files, for example. The other rule will validate those the various versions of each file, and finally the last one will control the printing of each map. On the other hand, the marketing department might have a couple of rules. The first one controls the advertising of maps, and the second one might control how the prices are changed and affected for the different products. Now let's go into the rule element, and the rule element, as we said, is the smallest building block. Okay, so that's the smallest unit of security control. You cannot break a rule down in terms of a set of other smaller components. It does have within it other components, but they have to all come together in order for you to define what a rule is. So those are the two most important components that a rule should have is what's known as a target and a condition. Okay, so we will explain next what a target and what a condition attributes are. But before we do that, it is very important just here to make the point that each rule will have some kind of decision which is included usually as an information in the rule, or some kind of metadata in the rule attribute, and that decision can be either a permit, meaning that if the rule is triggered, then it will permit. The decision that it will give is to permit the request, or it's a deny decision, meaning that if the rule is triggered or affected, then it will or the effect of that rule will be to deny the request. Okay, so these are the outcomes of evaluating a rule, in other words. Okay. But as we said, the rule itself will contain two very important elements, the target and the condition. So let's have a look and see what these things are. Or rather, let's first have a couple of examples, let's go back to the example that we were talking about, and let's have a look at a couple of rule examples here. So you have, first of all, a rule which was the rule controlling the editing for the publishing department. And that rule, for example, if you were to trigger it, then it will permit the whatever the request was. On the other hand, also here you have a rule which is pricing, and if you trigger it, it will permit. So you can write these. The actual specification of all of these things will ultimately be down to your security requirements and your security policies in the organization. Now, let's have a look and see what the target element consists of. And at this point, you will start seeing that things become clearer. Why? Because the information now that are included in your target are basically the same information that we talked about last time when we talked about access control policies. Okay, so remember we said there were three very important things that's an access control policy or model basically is built on, and we said those were the subjects, the objects, and the permissions. So these are precisely mapped here. So you have the subjects element, you have the resources element, and you have the actions element, and these map precisely to the subjects, objects, and permissions elements that we talked about last time. Plus, there is also something called environments or environment element, and that is essentially an element that allows you to group any other information relevant to the policy related to a specific resource or number of resources that you cannot classify as either actions, resources, or subjects. On the other hand, a condition element is basically just a single logical condition. So you write a logical expression, a logical formula that must be satisfied if you wanted to trigger that rule. Okay, so if you wanted to trigger that rule, this condition must evaluate to true. Now let's have a look at the subjects element. So as you will have noticed, it is a plural element, meaning that you would expect within this subject element to have any number of individual subject elements, so singular subject elements. And the idea behind that is that you may want to write your rule so that it applies to multiple subjects. Okay, so not a single subject, but multiple subjects. So you may want to write a rule that applies to not just Alice, but also applies to Bob, Carol, James, and so on. So therefore, you have that ability because the top level element here is a plural one, and therefore you can include any number of individual subject elements in it. So as we said, any of these subject elements essentially reflect the identity of the subjects that you want to control their access to your own internal resources. In this example here, we would like to write our rule, okay, which is part of a policy, which could be then part of a policy set, to apply to a particular individual called John Smith. And therefore, we would include within the subjects element an individual element subject here. And we always have to encapsulate all our data with something called attribute value. Okay, so this generic element attribute value is an element which is used to essentially say that what you will see next encapsulated is some piece of data. Okay, and in this case, the data, of course, is further given the type of subject, which is part of the larger type of subjects, which itself is part of the larger type of target, rule, policy, policy set, and so on. Okay. So that was subjects. Resources is pretty similar. Again, notice it's resources in plural, and the reason is because you may want to use your rule here to control not just one resource, but to control access to multiple resources. Okay, so you may want to say that the current rule I'm writing applies not just to my printer, but applies also to my local server, to my web server, all my laptops in the department, and in fact any other resource that you want to protect under the same rule and under the same policy. And so therefore the element resources as a result allows you to include any number of individual single resources in the policy. So here is back to our previous example. We specified that the rule would apply to somebody called John Smith, but now we are relating John Smith's requests to a particular resource, which is UK geographical maps folder, for example. Okay, so in this case, we're saying that this particular rule applies to all those instances where John Smith is attempting to access the folder which consists of or which contains UK's geographical maps. So that's the specific individual resource that we would like to protect. And of course, if you had multiple resources that also apply to the same individual person, that you wanted to protect them from that person, then you would list all those resources under the resources attribute. The next one, or the next element, is actions. Again, notice that this is a plural actions, meaning that you may want to be writing your rule in relation to any number of types of requests that would come from that particular subject or subjects going towards accessing that particular resource or resources. Okay. So in this case, again, we see inside the actions element, we see a number of individual singular action elements. Okay. And as I said, these map directly to the idea of permissions that we talked about, or the programs that you want to execute in your environment or applications, whatever those, whatever the definition of an action or a permission to execute an action is. And if we look at our example here, we will see, or we can say basically that we would like to control John Smith's attempt to access the resource called UK geographical maps in terms of two particular specific actions. Okay, so the first one is the read action, and the second one is the write action. Okay, so basically we're saying that this particular rule that we're writing now applies to those instances when where John Smith is attempting to either read or write the folder or the file which is called UK Geographical Maps. And again, note, and this is very important to be technically correct, that each time we are including some data, and in this case, our data is the information that we're given, either whether that information is related to the subject's names or IDs or the resources, or to say what kind of actions or even environments, as we will see later. But in all of these instances, the data that we're given to the policy must be encapsulated with this attribute value, because that is a value, if you think of it, for this particular attribute. And so are all the other ones as well. Now, we said that the last element was environments, and the environments element is nothing other than just a generic placeholder. Okay, so it's a generic placeholder where if you wanted to include, let's say, other information related to the rule that you're writing, and you cannot, let's say, classify or describe that information as either information related to subjects, resources, or actions, then you can use the environments attribute as a generic placeholder for you to include that information, additional information. So generally that would be, or a good example of that would be information related to the context, okay? And context very simply could be things like the time of the request, or the date of the request, or the location of the request, or indeed any other contextual information. So that's a good example of information that you cannot say or you cannot describe as being either information of type subject, resource, or action, and therefore you must include it, or you can include it as part of this generic placeholder attribute or element known as environments. So again, it's a plural, and therefore you can include any number of individualized or individual environment, singular environment elements in it. So to demonstrate this, we go back to the example. In here, we see that we have specified that not only the request coming in will be related to John Smith attempting to read and write UK's geographical map folder, but also that the request is related to a specific time in the environment or in the context, which is 13 hours or 1 o'clock p.m. Okay, so if the request came in at this specific time, then it will be relevant to this rule that we are writing, or this target in this case that we're writing in. Okay, if it's coming at any other time, it means that the whole target becomes irrelevant. Okay, so that's an important point to note here, that if any of these elements did not match with the information coming from the request, then obviously the target, and in this case therefore the rule, would not apply. Okay, it becomes just irrelevant to the request. Right, so that was all specifying the target, and the idea why we call it the target is because you can think of it like this, is that this is the target information. Okay, so you have a request coming in, and that request has a specific target, or it's attempting to go somewhere, which is your resource. Okay, so it encapsulates all the information related to the target, and that information, as we said, are the subjects, resources, actions, and environments information. Now, the second part of a rule, as we said earlier, is the condition. Okay, so the condition is a single condition. So note that it's not multiple conditions, it's a single condition. And it basically expresses a single logical expression or a logical formula. Okay. Um, and if you wanted to understand what logical expressions are, you can search offline for those. Essentially, this is a form of predicate logic, first order predicate logic. All what you're doing here is you are taking certain, or you're checking that certain statements have some logical values, either true or false, and then you can combine those with logical combinators like and, or, XOR, implication, and so on. So in this particular example, we have, in fact, three checks that we need to make. And we are connecting all those checks with the AND operator. Okay, so we're saying that it has to be the case that for this whole condition to be true, that all of these statements or these expressions, sub-expressions, have to also be true. But you could have, of course, if you had a different requirement and you wanted to make it an or an XOR, or you can build any logical condition that matches your particular security requirement that you're trying to implement in this case. So in this, so here the first expression is essentially checking that the resources ID is equivalent to the value National Geographic, and further on, it's checking that the request time at the subject, okay, or the request time for the subject, it was somewhere between 9 o'clock in the morning and 6 o'clock in the evening. And then finally, that the current day is a weekday. Okay, so it's sometime between Monday and Friday, and it's not a weekend. So if all of these sub-expressions were true, then the whole thing becomes true. If, in this case, either of these three was false, then the whole thing becomes false, and therefore the condition becomes false, and therefore the rule does not apply. Okay, so remember, the idea here is that the condition must be true in order for the rule to apply as a whole. Now we come to an important part of this, which is rule combining algorithms. So as you would have seen all the way up here, we said that a policy is a number of individual rules. Okay, so a policy is nothing more than just a collection or a set of individual rules. And we saw how you can query these rules, whether they apply or don't apply to a particular request. And as a result, we also said that if they did apply, then the effect of the application of the rule would be either to accept or let's say permit or deny the request. Okay, so if the rule was applicable, it will have an effect to say either permit this request or no, don't permit this request because the request is actually a dangerous one and therefore you must deny it. Okay. However, because we have multiple rules in a policy, those rules might have variety of effects. Okay, so some of them will say deny, some of them will say permit. And in some cases, we might have inconsistencies, or we might have situations where multiple rules apply to the same request. So, what do we do in that case? How do we resolve this situation where you have, say, 3 or 4 rules at the same time applying to the same request, and some of those rules are saying permit the request, and some of the other rules are saying no, you shouldn't permit it, you should deny this request. So this is the job, or let's say this is where we need what we call a rule combining algorithm. Okay, so a rule combining algorithm allows us to combine those decisions, which could be different, into a one final outcome. Okay, so we want to give one final outcome. Of course, like any other algorithm, you can write a rule combining algorithm in whichever way you want to write it, but there are a number of predefined algorithms that are used widely. Okay, so the first one is a deny override, or what we call a deny first. Okay, so the idea of a deny override is that if you had a single rule that came out saying deny, then that rule will override all the other rules. Basically, if you have 10 rules, 9 of them say permit, 1 of them says deny, then the outcome will be deny, okay, because the deny overrides every other decision. So that's easy. The opposite of that is a permit override, and the idea of permit override is simply that if you have one single rule saying permit and all the other rules were saying deny, then you will select the outcome of that rule that is to permit the request. Okay. So the deny override, in other words, is very cautious. The permit override is the least cautious of all. It's more kind of configured to allow things to move forward, okay, so that you can do things. There is also something called first applicable, and if you saw in the slide when we talked about the policy here, if, as you can see, we said that the policy consists of a number of rules. Now, the first applicable makes use of the order in which you are writing these rules. Okay, so it makes use of the order in which you're writing these rules. So it essentially says evaluate these rules sequentially. Okay, you start from the first one. If it applies, that's it. You take the decision of that rule. If it doesn't apply, you go to the next one. Okay, you evaluate it. If it applies, then you take the decision of that rule. If it doesn't apply, you go to the next one, and so on. Okay, until you've exhausted the list of all of your rules, and hopefully the first one that applies, the first one that can be triggered, and it can give us a decision, will be selected. Okay, and then we ignore everything else that comes after that. However, of course, if none of these rules that we have in our list actually applies, then we can just come back with the decision not applicable. Okay, basically we're saying that the request that came in didn't match any of our rules, and therefore the current policy that we have, that we're looking at, is not applicable to this specific request. So that's what the idea of rule combining algorithms are. Of course, there are also algorithms that combine policies. Okay, so in the same sense that we said that a policy is a set of rules, we also said that a policy set is a set of policies. Okay, so again, you can cascade the decision for the policy into a policy set. So you would have multiple policies all coming back with multiple decisions, or would, each one of them would have its own decision, and therefore you would like to combine those multiple decisions into a single decision at the level of the policy set. So that would be the decision of the policy set, in other words. So again, in order to do that, we have other algorithms that combine the decisions for multiple policies, and those are called policy combining algorithms. And again, you can write them in whichever way you want to write them, but there are some predefined policy combining algorithms, which also more or less they mirror the same ideas that we saw earlier with the rule combining algorithms. Now, I wanted to talk about another thing which is more kind of a structural. So the idea of a target, as we said, is something that specifies the information related to the target of the request. And we said that that occurs at the level of a rule. However, say if you had 10 rules and they all have the same target. So basically, they're all talking about the same subjects, resources, actions, and environments. Okay, so in order for us to save ourselves from replicating this target across all the rules, XACML allows us to do something very nice, which is to extract that target element and put it at the level of the policy. Okay, so if you see a target at the level of the policy element, that means that that target applies to all the individual rules which are written within the policy. Of course, again, you might have a scenario where you have a generic target and you can have one specific rule which has its own individual target. So in that case, the individual rule targets will override the policy target. Okay, so the rule target always overrides the policy target. And you can use the same idea again at the level of a policy set. If all these policies that you're writing have the same targets, then you can extract that and abstract it to put it at the level of a policy set, which means that all these policies have their own all these policies share the same target. But if any policy had its own target, then that target will override the policy set target. So that was the idea of how you can sort of move up the target at each level in order to make your life easier if that target is being shared across the elements at the next level downwards. Now, one thing I didn't mention as well is that sometimes the information included in a target may not be there. Okay, so for example, you may not see any subjects, or you may not see any resources, or you may not see any actions. And if any of these elements, or indeed any environments, So if any of these elements were missing, the idea is that that target then applies to every single instance of that element. Okay, so if you decided, let's say, to remove your subjects, okay, and you only included resources and actions, then that means that you are saying here that the target applies to every subject. Okay, it's not just John Smith. It applies to every particular subject who is attempting to access this particular resource with these couple of types of actions. And it's not just specific to the specific subject that we had written, which was in this case was John Smith. Similarly, if you remove the resources element, so again, this says, well, we want to make sure that we control any read and write actions coming from John Smith, regardless of the resource they're being directed towards. Okay, so it doesn't matter if it's UK's geographical maps or some other kind of folder or printer or whatever it is. It doesn't matter as long as we can see that the request is a request of read or write coming from this particular individual. Of course, the most restrictive, or the most, not restrictive, but the most general policy target, or a target indeed, is one that contains no information. Okay, so that is basically a target saying this rule applies to everything. Okay, so applies to every subject, every resource, every action, and every environment. Right, so to conclude, last couple of slides. First one, very quickly, there are lots of implementations out there of XACML. So if you were in a situation in the future where you wanted to, let's say, design a solution based on XACML for your organization or company, these are a number of what we call engines, okay, XACML enforcement engines. They basically allow you to set up an access control solution based on XACML. So you can get these. I believe some of these are open source, free source. Some of them are not, but that model, the business model, varies all the time, so don't take my word for it. And there are also obviously other engines as well out there, but these are just a few examples. The last slide is just showing you where you can get the Oasis specification documents for XACML version 2.0 and also version 3, and basically you can use these to get more extensive understanding of the language. Okay, so you can use them as your offline study to try to understand better what the various elements of an XACML policy or policy set document would be. Okay, so that is all. Thank you very much for listening. Goodbye.